Okay, well, thanks everyone for joining us virtually at Eureka McConnell Science Museum here in Grand Junction. And we're so excited to be able to have Dr. Dan May talking about the God of Prime Numbers. Here at Eureka, we also have a couple of events coming up. We have an online auction starting tomorrow and a virtual fundraiser with presenter next Wednesday night, with the title being "You Think 2020 is Bad? Try 66 million years ago after the asteroid." So you can log into that next week as well. And with no further ado, I'm going to turn this over to Emily May to introduce her brother Dan.
Thanks, Bea. Yeah, I'm really excited to introduce today's speaker. Today's speaker has spent many years doing math outreach above and beyond his professorship, including a summer program for underserved middle school students of New York and LA. He's also done in-service workshops for South Dakota middle school teachers. Dan also happens to be my brother, and so over the years I have had the privilege of hearing him do math talks in a variety of settings, and I've always been impressed with his ability to demystify advanced mathematics concepts for me. So today he will be talking about his research into the connections between math and poetry, which are two of unexpected subject areas. So I think it'll be really interesting, and I can't wait to learn how to write my own math poetry. So I'm very happy to introduce my brother, Dr. A, Associate Professor of Math at Black Hills State University.
Wonderful. Thank you, Emily. I appreciate that. Thank you all for being here. Can everyone hear me all right? Yes, cool. And so I may also occasionally use the chat, so I'm going to just type in hello here in the chat. If anyone wants to chat with me, maybe we can do that. But yeah, I'm very pleased to be here. I'm very grateful to have this opportunity from the Eureka Science Museum down there in Grand Junction, Colorado. Thank you so much for inviting me. I'm very excited to be talking today about mathematical poetry, history, and practice a little bit. I suppose that if we were in a room together, I might try to do a little bit more collaborative and interactive things. You maybe have to deal with just listening to the sound of my voice more than you might want to otherwise. But maybe I'll try to encourage people to do some writing. And by all means, please, 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 if you wind up writing some mathematical poetry, send it to me. Can you all see me writing on the slide right here? Let's see. I have your faces minimized, so when I ask questions, you can actually speak out loud or put something in the chat. Yeah. Yeah, good. Folks are seeing me. Yeah. So if you decide to play around with mathematical poetry, I would love to see what you come up with. So send me. My email address is right here, and I'll share this a couple more times throughout the talk. But with that in mind, let's go ahead and sort of get started here. And so just as a little prompt here, I want to point out a couple of mathematical haiku that I'm aware of. Christina Carroll here says, "There's not enough room in 17 syllables to contain in fin." That's supposed to be a joke. Kevin Ferry gives us a haiku here that I think is meant to be sung. Co-secant you say by the dawn's earliest light is 1 over sine. There's some math jokes in here. A squared plus b squared results in c squared each time, Pythagorean, and so forth. And so you probably or potentially maybe have heard about haiku before. Haiku are a very simple mathematically structured form of poetry where we just have this short integer sequence where the first line traditionally contains 5 syllables, the second line contains 7 syllables, and the third line contains 5 syllables. And so if you get bored listening to me talk over the next 30 or 40 minutes, by all means, type up a mathematical haiku and share it with us in the chat. I would love to see that. And of course, if you're going to have multiple lines in the chat, you want to hold down shift as you hit enter between lines. But yeah, feel free to share a mathematical haiku in the chat if you want to, or you can just kind of email this to me later if you'd rather not try to juggle too many things. Like I said, if we were in the room together, I would be making you write, and I can't really make you write in Zoom. So a little bit of a roadmap for what we're even doing here today. We're going to talk fairly quickly, I think about three categories of mathematical poetry. So we have poems which are literally about mathematics. This could be poetry that presents a math problem in verse. This could be poetry that is about historical developments in math. This could be poetry about the poet's individual experience of being a mathematician. There are various ways that poems can be about mathematics. We have mathematical metaphor in poetry. This is the second category, where the poet might use mathematical language or even symbols in a metaphorical context. And then my favorite category is mathematically structured poetry. And I'll try not to be overlong in that topic, but that is my favorite of these three categories, is poetry where the structure is mathematical, such as in the short integer sequence 575 in the case of haiku. So to start off with here, we have poems about mathematics. And I think I start off here with a fairly old example of this. So, this poem is, I don't know, around 1,000 years old. This comes from Bhaskar's Lilavati. And I think maybe I'll try to read this. Bhaskar was an Indian mathematician and poet, writing quite a long time ago. And so he writes, 10 times the square root of a flock of geese, seeing the clouds collect, flew towards Lake Manasa. 1/8 took off for the Stala Padmini forest, but unconcerned, 3 couples frolicked in the water amongst a multitude of lotus flowers. Please tell, sweet girl, how many geese were in the flock? So I think this is a really kind of a beautiful poem. One of the things you'd notice in here is this phrase, sweet girl. And what's actually happening in this poem is that Bhaskar has actually written an algebra textbook framed as a sequence of poems to his daughter. And so that's where this sweet girl comes from. Bhaskar, the poet mathematician, is addressing his daughter. And this is kind of a nice problem here. If we get a chance in the question and answers maybe later, we could actually do a little bit of algebra to solve the algebra question that is in this poem. But I don't want to linger here too long right now. Perhaps we'll come back around to this if folks want to. Here's a much more recent example of a poem that is literally about mathematics. This slide is not so good. This is just like a scan of a page from Sarah Glass's book, Ode to Numbers. This is a really nice poem she presents here about the history of calculus. And I won't read all of this here because this is pretty long. But Dr. Glass writes, I tell my students of the story of Newton versus Leibniz, the war of symbols lasting 5 generations. And she goes on to talk a lot about the parallel development of calculus. And so, yeah, this is a nice poem about mathematics. And you notice something else Sarah is doing here is making use of some actual mathematical symbols in the poem itself. So that's kind of a fun thing that she's doing as well. Let's see, next up here, I think I have, oh yes, okay, there's a picture of Dr. Glass and a picture of her book. You picked this up. This really is a wonderful book containing a lot of mathematical poems. So, you can look her up if you want to do that. Oh, and by the way, I also had wanted to point out that Sarah Glass is, I think, one of like the major and important figures in the modern mathematical poetry movement. So she's a very important sort of like figure at the center of our community. And another important figure near the center of that community is Dr. Joanne Growney. And she writes a lot about her experience as being a mathematician and a woman in math, stretching back to the 1960s and 70s even. And so this is a very long poem that she has called My Dance is Mathematics. And after sort of an introductory little quote here, I'll read you just a little bit down here. So Joanne writes, they call you Der Nother, as if mathematics was only for men. In 1964, nearly 30 years past your death, I saw you in a spotlight in a World's Fair mural, Men of Modern Mathematics. And so what Joanne is writing about here is her experience of coming into contact with a memorial for a very famous 20th century mathematician named Emmy Noether, who is a German mathematician, and quite distinctly not a man of modern mathematics. But when Joanne was watching this World's Fair mural, you know, there didn't even exist language to include women in mathematics. So that is, oh, and I think my next slide here. So I want to give a shout out also to Joanne's really, really wonderful, wonderful blog. I'm not sure if you can see this so well on this slide, but poetrywithmathematics.blogspot.com is Joanne's blog called Intersections. And this is a great resource for anyone who's interested in learning more about the modern mathematical poetry community. You know, Joanne has really been like a tireless archivist of this movement. Yeah, so let's see, I think my next slide here. Oh yeah, okay, so that, you know, so we now move into mathematical poetic metaphor. This feels so weird to just be like lecturing forth. I mean, any comments, questions? I see some things happening in the chat. Thank you, Adam, for sharing some mathematical haiku there, and Dr. Fuqua for commenting on. Anyone want to like speak a question or a comment here before we move into the second section? Well, we're definitely going to leave time at the end of the session here for questions and answers. So, you know, I hope to have more time for a more robust like exchange here. And I'm trying to drop some breadcrumbs along the way for you all. Like if you want to circle back and actually solve Bosker's algebra problem, we can certainly do that at the end of the talk. So the second type of mathematical poetry that I will discuss here a little bit today is what we might call mathematical poetic metaphor. So this is a situation in which the poet uses mathematical language or imagery in a metaphorical way. Now, you know, this is something that is perhaps not well known, but Emily Dickinson did this to some extent. And so, you know, there's a number of poems that Emily Dickinson wrote that employed this mathematical metaphor. And one of my favorites is right here. And so I think I'll read this one for you. We shall find the cube of the rainbow, of that there is no doubt. But the arc of a lover's conjecture eludes the finding out. What is this poem saying? What is Emily Dickinson trying to say here? Thoughts?
Well, it's harder to calculate an arc than a cube.
Hey, yeah, I like that. Yeah, that's cool. Yeah, yeah. So an arc is like a curvy thing, and a cube is a straight line thing. I like that. I like that. Yeah, that's cool. Other thoughts on this poem?
I think she's reflecting on, you know, we can learn about the universe. That's an easy thing to do, to study the rainbow, but to try to figure out the arc of a lover's conjecture, that's just beyond us.
Nice. Yeah, I like that, Adam. Thank you. Other thoughts or comments that folks want to share?
It's kind of nice to think about the specificity of math compared to how nebulous or like cloudy love might be.
Okay, yeah, I like that. Thank you, Colleen. Yeah, so I think that those last two comments, you know, some commentary has been written about this poem that this is indeed Emily Dickinson sort of you know, maybe making a commentary about the demystifying of something like a rainbow when, you know, and I don't want to come off as anti-science, of course, but, you know, Emily Dickinson is sort of pointing out that there's a certain romance in the mystery of love. And, you know, perhaps some commentators have suggested that she's saying that understanding the science behind a rainbow sort of demystifies that. You know, personally, I kind of think we can hold both views in equal prestige simultaneously. What else do I have in here? So I think my next poem here Yes, Langston Hughes. All right, so Langston Hughes, you may know, the leader of the Harlem Renaissance in the early part of the 20th century, and he has this really wonderful poem that's actually using mathematical notation here to say something. So Langston Hughes, his poem Addition 1 goes like this: 7 times 7 plus love equals an amount infinitely above 7 times 7 minus love. I think this is a very nice poem. Anyone want to make a commentary either in the chat or out loud about this poem?
I really like this one. This is definitely my favorite one that you've shared. It's simple.
Oh, cool.
It gets to somebody who's not a mathematician, easy to understand, but I really like this one.
Cool, thank you, Lizzie. I think, I'm actually going to do a little bit of math here for you. So I think that this poem, I'll do a little bit of algebra for you here. I have my notes written down here. So I believe Langston Hughes actually implies like a value of love in this poem. So if we do a little bit of algebra here, 7 times 7 plus love equals 7 times 7 minus love. But wait a minute, he says that the plus love side is infinitely above. So I think that means you have to add infinity to the minus love side to balance this equation. Well, if you remember your algebra, I suppose we could subtract 7 times 7 from both sides of this equation, which would sort of cancel out the 7 times 7s. And so we wind up with love equals negative love plus infinity. I suppose we could add love to both sides of this equation. And algebraically speaking, what is love plus love?
2 times love.
I think it's 2 times love. Very good. I think so. I think it's 2 love equals infinity. Okay. Well, I suppose potentially we could say multiply both sides of this equation by 1/2. If we're doing some algebra here. And so I believe that Langston Hughes is telling us that love is 1/2 of infinity. What is 1/2 of infinity? Well, I guess mathematically, half of infinity is still infinity. So we have a bit of a paradox here. I think kind of a nice paradox. I think Langston Hughes is telling us that love is not only half of infinity, but all of infinity itself. What is the other half of infinity? Well, I'm not so sure. But I think this is a very nice poem.
I've seen that infinity symbol used to mean love, and I'm wondering if this was written, maybe this was written like in the 30s or 40s, or I don't know. I'm wondering when that infinity symbol came to mean love.
That's a great question. Yeah, I love that. I have this book in a. I don't have my Langston Hughes book right next to me here. I think it's downstairs. I tried to have all the books that I was referencing here next to me, and I don't have that. So yeah, I'm not sure. I like that comment. Good.
But Dan, this is the best close reading of a poem I think I've ever heard. Just FYI.
Well, that's no small praise coming from this is my dean, Dr. Fuqua, English prof. So yeah, thank you for that. Yeah, oh, go ahead. Yeah, comment.
I would just also mention that that to love might be a play on words. To love equals infinity.
Ah, I love
it. And not to get too pithy, but to love is the infinitive form of the verb love, right?
Indeed. This is very nice. Very nice. Yes, you're blowing minds, Adam. Here, I love it. This is good stuff. Thank you for that.
That's it for me, everybody. That's my last.
No, that's awesome. That's awesome. Yeah, let's see. So yeah, there's some interesting questions in the chat here about what background in math Emily Dickinson or Langston Hughes had. That is, I don't know the answer to that question, Carrie, about any kind of formal training Emily Dickinson might have had in math. That would be something for me to learn more about. Let's see, I think my next example here is actually the title of my talk. And so the next poem in here is from the really wonderful Alice Major. I actually do have her book to wave at you here, called Standard Candles, from the University of Alberta Press in 2015. Alice Major was the poet laureate of, I believe, Alberta for a while. And she is really like a wonderfully science-minded poet. Pretty much all of the poems in this collection tie in science or mathematics in some way. And this is one of my absolute favorites of hers. And so I'm going to read this to you, and then we'll maybe discuss this a little bit. The god of prime numbers, Trinity, Quintic, indivisible 7, visits her creation often in its early moments, then draws away for ever-lengthening periods. Oh, how long must we inhabit a dreary world of common factors till her return? I love this poem. Does anyone want to offer any commentary on this poem? A little abstract. This is abstract.
I like the line that says, then draws away for ever lengthening periods. It makes me think of how prime numbers are unique. And, you know, she comes back to that idea in the dreary world of common factors. And
Yes.
it kind of gives prime numbers, it's like personification kind of prime numbers. It gives them a little bit of a personality, which I like that.
Very cool. Very cool. Thank you for that comment, Emily. It occurs to me that maybe I should take a short side trip. Do folks know what is a prime number?
Has no factors.
Indeed, no factors. Indeed, no factors, no non-trivial factors. Can somebody name a prime number for me?
7.
7. Very good. I like it. Yeah, 7. Because the only way we can write 7 as a product of two whole numbers is 1 times 7. Whereas, can somebody give me a whole number that is not a prime number?
9.
9. Very good. 9. Because 9, how can I write 9 as two numbers being multiplied together, neither of which are 1?
3 and 3.
Yeah, 3 times 3, exactly. Exactly. So 7 actually, as it turns out, is a prime number because the only way we can write it as a product of whole numbers includes 1 and the number itself. Whereas 9 is what's known as composite, or, you know, like not prime, maybe would be a more direct way of saying that. And so I believe that, like you said, Emily, Alice here is personifying the prime numbers as a sort of a deity here. You know, when she says Trinity, she's referring to 3, which is a prime number. When she says quintic, she's referring to 5, which is a prime number. When she says indivisible 7, she's referring to, well, clearly 7, which is a prime number. And when she says that the god of prime numbers is visiting her creation often in its early moments, she's actually referring to the fact that early on in the string of positive integers, we wind up seeing prime numbers quite often, right? If I just list all of the prime numbers which are less than 20, I think I see 1, 2, 3, 4, 5, 6, 7, 8 of them. So we see prime numbers quite often early on in our list of positive whole numbers. However, as you move along this number line, prime numbers become less and less and less common. Fewer and fewer whole numbers are in fact prime numbers as you move along the number line. And so what she's saying is that the god of prime numbers is actually drawing away for ever lengthening periods from her creation, her number line. And in fact, I think my next slide here might bring some of this into focus, I hope. So to be a little bit more specific, if we were to write down all of the numbers between 1 and 100, 25 of those would be prime. If we were to look at all of the numbers between 1001 and 1100, only 16 of those are prime. If we look at all the numbers between 100 and 1001 and 100,000 and 100, only 6 of those are prime, and so forth. The idea being that as we move into larger and larger and larger positive whole numbers, prime numbers become rarer and rarer. And I think Alice is drawing our attention to that fact. But the reason that I love this poem so much is because it's not just a commentary about how common or rare prime numbers is. But I think she is also making some religious commentary here about a deity visiting its creation many times in the early moments of that creation, but then drawing away for ever lengthening periods. I mean, I think that I think that folks can maybe draw an analogy between various religious perspectives that might have a deity being very active in the early days of the story and less active in the story later on. And in fact, the prime numbers behave rather, you know, the prime numbers are fickle, because if we were to take another row in this table, we would see that now all of a sudden there are 6 prime numbers, you know, in the first 100 numbers of the 100 million range. Now, so the prime numbers do draw away for ever lengthening periods, but they don't necessarily do this in a predictable way, which is perhaps the same way Alice is suggesting a deity operates, in a ever drawing away, but not in a predictable fashion. I think this is really a beautiful and really rather deep poem. And that's why I titled my talk after it. Amy, I think you're muted right now. Are you?
Oh, yeah. So this is super cool from a poetic standpoint, too, because, you know, poetry from the 18th century especially was looking at the idea that God, and historians I'm sure too, the Enlightenment idea that there was God as a watchmaker, and then God, divinity sort of left us to run on our own. So she does that with math, which is a great tool of the age of reason, which is kind of cool. And then she starts with Trinity, which, I mean, I'm not sure I understand Quintic well enough to figure out what the religious connection there is, but Trinity, you can't read that without thinking of a Christian tradition. So that's the start of things, and then things get, divinity gets more and more distant as you go, which is, Benjamin Franklin would love this.
Awesome. Thank you. Thank you for that. Let's see. So let's see. Okay. Oh yeah. And so then we move on. Now, you know, I was shooting for the like maybe 35 to 40-minute range here, and I think we're about on schedule here. So like I was saying, mathematically structured poetry is my favorite of any of these categories of poems. I really like this because it is possible to really hide some pretty deep and like surprising mathematical structure. And let me show you what I mean. So a very, very, you know, sort of old example of this is this square poem in honor of Elizabeth I. You know, this poem is, you know, nearing 500 years old at this point. And this is sort of hard to read, but I think this anonymous poet is saying a square in verse of 100 monosyllables only, describing the cause of England's happiness. And so she or he, you know, I'm not sure who the poet is, but describing the Queen, has written sort of this array of 10 monosyllabic words by 10 monosyllabic words. And so I believe that this poem is intended to be read in more than one way. So, you know, somebody who is reading this poem can read across the rows, God hath poured forth rare grace on this isle, and makes crowned your rule, Queen, in the fame, etc. I believe the poet also intends that this poem can be read vertically. God makes kings rule for heavens, your states hold blessed, hath crowned, well, I start to lose the thread on some of these words. Okay, there's some old English going on here that I lose track of. But the point is that this is, there's an array of monosyllables in this poem which are intended to be read in more than one way. Now, I'd like to point out that modern poets also play around with this type of poem. So in particular, Joanne Growney, who we were talking about just a minute ago, really just last year, had published this really, really wonderful little short piece in the Math Horizons magazine, published by the Mathematical Association of America. You can look this up if you like. This slide is kind of hard to see. This is the whole page of Joanne's piece. But she's writing these syllable square stanzas where she's doing exactly what the poem written in the honor of Elizabeth I on the previous slide is doing. 4 lines of 4 syllables each, or 5 lines of 5 syllables each. I'll call our attention to the 4x4 square. here. And I'll go ahead and read this one. So Joanne writes a poem called Little Women. In school, many gifted math girls, later, so few famed math women. Clearly tying this into her experience as encountering, her experience of encountering Emmy Noether in the 1960s. So this is a theme that Joanne really has explored in her poetry throughout her career. She's actually a retired professor of mathematics. I think she taught somewhere in, oh man, I can't remember where she was teaching. I apologize. I think she was in Pennsylvania somewhere. So definitely look this up. Another different type of structure. Oh yeah, we talked about math haiku. I think we talked about math haiku at the top of the hour. Daniel Matthews, you can tell that he's not American. How can you tell that he's not American by this haiku? Emily, I know you know the answer to this. I'm putting you on the spot.
Oh gosh, do I know the answer?
Sorry. I remember when you were in Kenya, you used to use this word a lot.
Oh yes, maths. Yes,
Yeah.
Exactly.
Yeah,
Yes, that's right.
Is,
we taught a British curriculum, and yeah, in England they, instead of math, it's referred to as maths.
Indeed. And Daniel Matthews is an Australian mathematician and poet, and he writes, maths haikus are hard. All the words are much too big, like homeomorphic. I think there's a really wonderful little joke in here. You know, as we have seen, you have this sort of integer sequence of 5 syllables, 7 syllables, 5 syllables. But now wait a minute. In this third line here, like, ho, me, o, morphic. Wait a minute, that's 6 syllables? So he's playing with the form a little bit, but in fact, he's playing with the form in really kind of a whimsical kind of way, because homeomorphic is a math word, but so is the word homomorphic. He really could have just crossed out that E, and it would have been a 575 poem, like homomorphic, but clearly he's just inserting this extra E here to sort of break the pattern. Which is, I think this is kind of a funny math poetry joke, but also, you know, I'll point out seriously, like there is a long history of poets sort of setting up these constraints and then very subtly breaking those constraints. And we could, you know, that's a rabbit hole we won't necessarily go down. But there is sort of, there's a joke here. I think it's nice. Let's look at another integer sequence here that some folks might know about. So 575 is a short sequence of integers. But somebody tell me when you recognize this one. I could write down a 1, and then I could write down a 1, and then I could write down a 2, and then I could write down a 3, and then I could write down a 5. Does anybody recognize this sequence? And then I could write down an 8. I see Adam nodding his head. Oh yeah, somebody in the chat points out this is the Fibonacci series. Yeah, thank you, Barbara. Awesome, very awesome. Thank you for that, Barbara. The next number then after this would be what?
13.
13, yeah, and how are we obtaining these numbers, by the way?
The sum of the prior two numbers in the sequence.
Exactly right, yeah, thank you, Adam, that's exactly right. The Fibonacci sequence is obtained by sort of, you know, writing down these two ones and then adding them together to obtain 2, and then repeating that process. Sort of adding together these two numbers to obtain this number, and again, repeating the process, adding these two numbers together to obtain this number, etc. And so indeed, you add the previous two numbers to obtain the subsequent number, and this is what's known as, yeah, the Fibonacci sequence, right there. All right, big deal. Well, you know, mathematically minded poets certainly couldn't avoid trying to repurpose this for our own causes. And so I present to you something known as the fib poem, in the spirit of the haiku, or a syllable square. We might say one small, precise, poetic, spiraling mixture. Math plus poetry yields the fib. Gregory Pincus is a writer of various different types of things. I think he's written some children's books and also some poetry. Kind of has his finger in different worlds of literature. In 2006, he presented this poem. Anyone notice what's going on here with this small poem?
number of syllables follows the Fibonacci sequence.
Nice, nice, very good, Emily. That's exactly it. Yes. If we sort of look at the syllable count of each line, we've got 1 syllable and 1 syllable and 2 syllables and 3 syllables and 5 syllables and 8 syllables. Oh yeah, yeah. In fact, this is the form of poetry that Greg Pincus established in 2006. Although to be fair, mathematically minded poets had played around with the Fibonacci sequence before this, but this really kind of blew up. This became famous. This was covered in the New York Times back in, the spring of 2006. This really kind of became a bit of a fad and a very popular thing for folks to take a look at. And like I said, there's lots of other poets that have incorporated the Fibonacci sequence in their poetry. Dr. Fuqua, you might remember you and I had a conversation about Sherman Alexie and the Fibonacci poetry about a year ago, I think, in your office at one time. But yeah, so I'm gonna kind of shift gears here. I want to talk about 2 more types of mathematically structured poetry. Hopefully take no more than 5 minutes or so to do that and leave a good time for discussion and questions. So the next poem that I have here, and I'm not going to read this, this is a very long poem. This is the poem called Sestina by the wonderful Elizabeth Bishop here. I can't resist the first stanza. I'm going to make you all listen to me read the first stanza at least. September rain falls on the house. In the failing light, the old grandmother sits in the kitchen with the child beside the little marble stove, reading the jokes from the almanac, laughing and talking to hide her tears. This is really a deeply beautiful poem, especially for this time of year. We had some October snow earlier today. But if you read this poem closely, you start to notice something very interesting going on about the words at the end of the 6 stanzas, right? House, grandmother, child, stove, almanac, tears, tears, house, almanac, grandmother, stove, child, tears, etc. You notice that in fact, each of these 6 stanzas containing 6 lines each, all end in the same 6 words, outside of this like sort of mini half stanza thing, which, we talk about that some other time. And I think that's what the next slide demonstrates. Yeah, and in fact, what's going on here is the poet in a sestina is permuting the end words. What I mean by permuting is taking those same 6 end words and sort of shuffling them up in a prescribed manner. In particular, the prescribed manner is this sort of spiral pattern. So in the case of using the end words for the sestina here, well, the poet sort of spirals around. And so if I were to write house, grandmother, child, stove, almanac, tears in this order as in the first stanza, you sort of start from the bottom and you spiral, and you would end each of the subsequent 6 lines here with these words in this order. So you need to your first line of your second stanza needs to end with tears, and then you follow the spiral up to house, which is where the second line should end, and you follow the spiral to almanac, which is where the third line should end. And in fact, that's exactly what has happened here. You have sort of another thing going on where the ending word from the subsequent stanza becomes the word that ends the first line in the next stanza. So tears goes to tears, child goes to child, almanac goes to almanac. And then you sort of have this bouncing up and down. So sort of from the bottom, you move to the top, and next house comes next. And then you move second from the bottom, almanac comes next. And then you move second from the top, and etc. We could give in fact, I have given an entire talk only on sestinas, but I think I don't want to get too bogged down in the details here of this. There is some like really pretty non-trivial mathematics going on with the sestina. If we wanted to, we could describe that in terms of a permutation. Here is the permutation that these end words are permuted by. And in fact, I can't resist but at least mentioning quickly the French group, the Oulipo. This was a group of French mathematicians, poets, engineers, writers, and just general, troublemakers back in the 1960s that, one of the first things that the Oulipo did is generalize the sestina. And there really is some highly non-trivial mathematics in the generalization of this kind of poem. You know, can one write a poem like this where it's 4 stanzas with 4 words that sort of bounce around at the end of the lines? Well, it turns out you can't do it with 4 stanzas. The Oulipo was very interested in that. Another sort of famous Oulipo work was Raymond Queneau's 100 million poems. The idea being, as suggested by this picture, that Queneau sort of writes 10, 14-line stanzas where all of the rhyme scheme and the rhythmic structure matches from one poem to the next. And so you can sort of like slice these poems up into strips and sort of mix and match any combination of lines with any other combination of lines. And so Queneau actually winds up with 10 to the 14 different poems here. I guess this brings me to my last type of poem here, and I really don't want to feel rushing, but I do want to give a place of prominence to this poem. So my esteemed colleague, Dr. Courtney Hughes-Wyka, who is a really wonderful poet at Black Hill State University, published the following poem called Pine for Me in her book Perch in 2015. And I think I will read this all for you. And I want you all to see if you notice anything pronounced about this poem as I read it. When the turkeys bullet from their sleep, the pines feel their absence. They winter their silence, but I can feel their longing, the pining for something that once was, like the lost thrum of wing beats when winter skies sleep. My fickle heart is a red winter apple that has known at least one bullet. My fickle heart has slept in silence for at least as long as the pines have sympathized with the fracture of grackle hearts and the sincerity of nuthatch wings. But when the birds wing in the silence, all I can hear is the crack of the bullet. What do folks notice about this poem?
There's a lot of repetition.
A lot of repetition. Thank you, Adam. That's exactly what I was hoping somebody would say. What are some words that repeat?
Bullet.
Bullet. We see bullet here and here and here. Yes, I see some folks in the chat are making some comments. Yes, wings, heart, sleep. Yeah, I can't circle all of the repeating words fast enough that you all are giving me. But yeah, I'm very happy that you noticed that. And in fact, I think the next slide points that out. There are lots of repeated words in this poem. If I can get to the next slide. There. Right? Now, what is the mathematical structure of this poem? Well, this is actually a fairly complicated question to answer. And I guess I want to point out that this is actually a mathematical poetic structure that Dr. Hughes-Wyka and I developed together. This was a project of ours, some original research we did several years ago. But I would like to point out that there's this type of finite geometry which is known as a projective plane. And I guess, I won't get into the details of the projective plane axioms here. Any 2 distinct points have exactly 1 line going through them both. Any 2 distinct lines intersect in exactly 1 point. But basically, these are rules that define this geometric object, which is known as the Fano plane. And so as it turns out, if you were to name any 2 points in this diagram, they should be connected by 1 color of line. So let's play this game. Somebody just give me 2 points. Somebody name 2 points in this diagram. I see somebody. 2 and 4 in the chat. All right, yes. So 2 and 4. Well, what is the line that contains both points 2 and 4? Well, it's actually this black thing that looks like a circle. We consider that to be one of the lines. This is sort of the thing that gets folks with the Fano plane. By line, we don't necessarily mean like a Euclidean line. We just mean sort of like a curve or something. So 2 and 4 are both contained on the circle, which counts as a line. Give me 2 other points, if you will. What are 2 other points?
5 and 4.
5 and 4. All right. So sorry, chat. 5 and 4. What is the line that contains both 5 and 4?
The purple line.
The purple line, exactly. And in fact, we can play the same game with the lines. So somebody name 2 colors of the lines here. Just any 2 colors. I see in the chat, let's see, the chat gives me yellow and green. Awesome, thank you, Barbara. Yellow and green. And where do those 2 lines intersect each other?
At 7.
At 7, yeah. Give me 2 other lines. 2 other colors.
Purple and orange.
Purple and orange, thank you. Where do purple and orange intersect each other?
At 3.
At 3, that's right. And so this is really my favorite kind of mathematical object. Now, you might be wondering, why am I bringing this up in the context of Courtney's wonderful poem here? Well, in fact, her poem is what we have referred to as a Fano Plane poem. And so we actually use the Fano Plane as a template for poetry. We sort of fill in these 7 blanks with words and then write stanzas to these lines. So, for example, what's going on in Courtney's really great poem here is you see in this first stanza here, she has included the words, oh man, let's get that out of the way. She has included the words bullet, sleep, and pine. That is going to correspond to this line in the Fano Plane, because those 3 words show up on a line together in the Fano Plane. Which one of her stanzas is this line? That is, which stanza includes the words silence, winter, and pine?
The next one?
Yeah, I think stanza 2, exactly right, stanza 2. So each line in the Fano Plane produces 1 stanza of poetry. And what's really nice then about those Fano Plane axioms is that you have this sort of interconnectedness of the stanzas. So if I were to sort of just arbitrarily circle 2 of the stanzas here, well, these 2 stanzas are going to have precisely 1 shared key word. For these 2, what is that shared key word?
Heart.
Heart, yeah, that's right, heart. These 2 share heart. And what's more, if you were to pick any pair of key words, so somebody just name 2 of the repeated words from this poem. Any 2.
Winter, heart.
Winter and heart. These 2 words must appear together in 1 and only 1 stanza. Which one is it?
In the middle, 1, 2, 3, 4th one.
There it is. That's right. That's right. And so, there is a lot of repetition in this poem, but it comes in this really hidden way, in such a way that there's really a lot of harmony between the stanzas. All of the stanzas sort of share 1 and only 1 thing in common. And so we had a lot of fun with this project. If you want to know more about this, you could probably look up our paper. I think I have a quick reference to this here. I can show this again to folks if you want to. Dr. Hughes Wyka and I have sort of helped students write Fano Plane poems before. And so I kind of have some slides here that would help someone to actually write a poem like this. I don't want to linger on this. Maybe, I know this is being recorded. If you go back and watch the video, you can pause on this slide or something. Or if you want me to just send you a document that describes this activity of how to write a Fano Plane poem, let me know and I can send you the document. We have some sort of hints about how to do this. Using words that can be maybe a noun or a verb are helpful because it helps this repetition to stay fresh. You notice Courtney uses, wing, pine, and bullet as both nouns and verbs in her poem. And then all kinds of other math poetry prompts. I mean, there's so much you can do with this, and I really would be so thrilled if anyone dives into some of this mathematical poetry and wants to send me some stuff that they have. I think that is the end of my talk. I've gone maybe slightly longer than I wish I would have. Sorry about that. I hope that folks are not too like just Zoom fatigued to have some conversation here. Do folks have questions, comments, observations, complaints?
Dr. May?
Yeah.
The order of that poem, is that like, does that make a path on that geometric shape there? Like it kind of goes in a certain, like a walk, kind of?
Yeah. Hey, Elliot, by the way, thank you for coming. I really appreciate that you're here.
Oh, it's really cool.
You're talking about Professor Hughes Wyka's poem here, right?
Yes, yes.
So I would say that there, so folks, Elliot is a math student of mine who actually, like, you know a bit of graph theory, right? You're talking about graph theory.
Yeah, yeah.
And I would say that the answer to your question is no. So like a graph walk implies some sort of ordering of the vertices, but with the Fano plane here, you know, the symmetry suggests that there really is no order in which you have to visit these points. And so it's really up to the poet to decide. So, you know, like as Courtney is writing this poem, she knows that at some point she's going to have to write a stanza that includes bullet, heart, and winter. But she gets to decide where that stanza occurs. So it looks like for her, she decided that that should be, well, I guess the middle stanza, right? Bullet, heart, winter. But there was nothing prescribed that said that this stanza had to be the middle of her poem. This could very well have been the beginning of her poem. I think that addresses your question, Elliot.
Yeah, like are some of the poems, like just the way, like the order in which the stanzas are written, are they like do some of the authors maybe like purposely like create a path kind of on their family?
You know, that's a good question. I guess I have more to say about this.
Save it for class.
Yeah, Dr. Hughes Wyka's and I have another collaborative sort of poetry template that we came up with a few years later that did involve directed graphs, which is maybe a little bit more like what you're talking about. So Elliot, maybe you and I can follow up about this later.
Okay.
Yeah, that's a good question.
Danny, what about like the beat and the rhythm of a poem? I know that, you know, that's an important part of poetry. So and like Emily was talking about the syllables, so would that be part of when you would, how does that connect with math? I know like the number 7-5 with the haiku, but is there any, Langston Hughes, your Langston Hughes poem really made me think about that because Chris, your cousin, loves Langston Hughes also. And the big thing about him is reading it aloud and the rhythm and the beat with it. And indeed. I don't know, is that a math factor at all?
Yeah, you know, I think it certainly can be. I mean, we certainly have different like rhythm or like stress patterns. You know, you have like iambic pentameter, which sort of now I will say that this is what separates like the professional poets in the room, like Dr. Hughes Wyka here, from the dabblers and dilettantes such as myself, in that she has a better grasp of this sort of like nuanced rhythm of language. I think her poem does that really nicely here. You know, for me, this is one of the more subtle aspects of poetry that I sort of wrestle with. But I'm open to hear other people's take on this.
Okay, so the rhythm and the beat wouldn't be so much considered mathematical.
No, I think it very much could be. It's something that I don't know as much about.
Okay.
Yeah.
Okay.
Yeah.
Because that's my background more with poetry but it's kind of cool to see it applied within another discipline.
Yeah, I like. Thank you for that. Yeah. You know, that's something I know less about.
Okay.
Other comments, questions, thoughts? Any more poems here folks want to see?
Thank you, Dan, for presenting today. This was really, really great. And I love there were several haikus that came up.
Yeah.
And especially from Emily and Adam, who are both working with middle school students in the classroom with math right now. So they were both very fitting.
Do any of you want to read your haiku? I would love to like hear the poet read their work here, right in the talk. Does anybody want to do that?
Emily was saying earlier how much she likes to share her poetry with everyone.
Great friend you are. Golly.
All right, Adam, I'll go first, then you have to go next. All right. Yeah, mine is actually what I was helping with tutoring today in the 8th grade math class that I tutor in. The slope of a line, increasing or decreasing, a hill without snow.
I love it. Thank you.
And my background is in science education, and so I will often hear this from students. My least favorite thing when a student shares with me, I'm not a math guy.
Amy, I see you followed up that with a good comment.
Well, I did, but I didn't realize I was responding to a really super haiku with just some boring prosaic response.
No, it's good. Yeah, I like your comment a lot here because, I'm not a math guy. I'm not a poetry guy. Like, sometimes I feel like I've taken these two things that are like traditionally very terrifying to students and like mashed them together into this unholy, like doubly terrifying thing. But here we are.
Well, that leads to my haiku, which is poetry and math. I would not have guessed the match. Thank you, Dr. May.
Awesome. Thank you, B. I like that.
Thank you.
Yeah, well, unless there's any more questions, thank you everybody for joining in.
Send me what you come up with. I'm dead serious here. My email is on the screen here. You probably could reach out to folks at the Eureka Museum too, if you want them to get in touch with me. But I would love to see what folks come up with.
Sounds good. Thank you.
Cool. Thank you.